In this question, we determine the reaction at the supports. So, here is in the beam which carry a uniformly varying load, where trapezoidal load intensity is 900 Newton per meter and the rectangular load intensity is 600 Newton per meter. The length of the trapezoidal load is 3 meters and the length of the rectangular load is 3 meters. One end of the beam carry a roller supports and other end of the beams carry a pin supports. Now let us draw the free body diagram of this beam. So in roller supports, only one type of force which is in vertical direction, that is Ra. Similarly, in pin supports there is two type of forces. First which is in y direction, that is Rby, and other is in x direction, that is Rbx. Now we calculate the weight of this rectangular load. So the length of this rectangular load is 6 meters and the breadth of this rectangular load is 600 Newton per meter. So the weight of this rectangular load is equal to 600 Newton per meter into 6 meter. So this is equal to 3600 Newton, which is acted 3 meter from the roller supports and 3 meter from the pin supports. Similarly, we calculate the weight of this triangular load. The one side of this trapezoidal load is 900 Newton per meter and the breadth of this rectangular load is 600 Newton per meter. So the base of this triangular load is 300 Newton per meter. So the weight of this triangular load is equal to half base into height. So the base of this rectangular load is 300 Newton per meter and the height of this triangular load is equal to 3 meters. So this is equal to 450 Newton. So this is the weight of this triangular load, which is acted 5 meter distance from the pin supports. Now we apply the condition of equilibrium. So summation of all the forces in x direction is equal to 0, summation of all the forces in y direction is equal to 0 and the summation of moment is equal to 0. So let's start with the forces in x direction. So in x direction there is only one force, that is Rbx. This is equal to 0. Now summation of all the forces in y direction. So in y direction, take upward is positive and take downward is negative. So in upward direction there is two type of forces, Ra and Rby. So Ra plus Rby minus 450 Newton minus 3600 Newton equal to 0. So reaction at A, reaction at By is equal to 450 plus 3600, this is equal to 4050 Newton. So take this equation 1. Now we calculate the summation of all the moments at B point equal to 0. So the reaction at A, which is 6 meter distance from the B, so this reaction takes a clockwise direction. So this will exert a moment in clockwise direction. Similarly 450 Newton, which is 5 meter distance from the B, and this will takes anti-clockwise direction. So this is 450 into 5. Similarly 3600 Newton, this will also exert a moment in the anti-clockwise direction. So this is minus 3600 and the distance from the B is 3 meters. So the reaction at A is equal to 2175 Newton. Now we calculate the reaction at B point. So put the value of reaction at A is in equation 1. The reaction at A plus reaction at By is equal to 4050 Newton. The reaction at A is 2175 plus reaction at B. Solve this value and we get the reaction at B is equal to 1875 Newton. So this is the final answer.